Okay, so a quick part 2 video. This is going to go through what you need to do if you're changing your capacitor values to values that are higher than 100 microfarads in order to get an accurate reading from your ripple voltage. Now, as we can see, once we've clicked on our 100 microfarad value, my waveform is a lot bigger than the ones that will be on yours. And that's due to the fact that I've changed my oscilloscope settings. So I've increased the scale, and I've also selected the AC section, or the AC setting on the oscilloscope. If it was on DC and we've changed these settings from what it was before, you'll see as we decrease this, the waveform disappears off the page. If you click AC, it magically appears back again. Once you've got it back, you repeat the same process of sliding the tabs across to the top and the bottom of the waveform, and that will enable you to get a much more accurate ripple voltage reading. It doesn't affect the multimeter. If you double click on the multimeter, the same way as we did before, you'll be presented with an output voltage across the load resistor, and that's not affected by your oscilloscope settings. Now, this is particularly important if we want to go and change the size of the capacitor to a pretty hefty 1000 microfarads. So I'll have to stop and start the simulation again. Stop and run. And if we now click on the oscilloscope, we will see that the ripple voltage has decreased quite a lot, but we can still change this in order to increase the size and the visible size in order to get a more accurate reading on our waveforms. Here we can see now it's only about 100 millivolts, and that's what's changed. You'll struggle to get a decent kind of peak voltage from that, but you can state in your report that due to the fact that we'll concentrate on the ripple voltage, you click the AC button, you get a more accurate ripple voltage. If you did want to reference the peak voltage, you have to click back onto DC. You won't be able to see the waveform, but you will still get a reading from there and an output from that. So that's something you can do if you're looking to get a more accurate reading on a much higher level of capacitor. What I will do is I'll do another video with the whiteboard and show you some calculations you can put into your report. Again, what that'll enable you to do is link the behavior of this circuit to some electrical theory, and you can base your analysis on that. But essentially what's happening is the bigger the capacitor, the smaller the ripple voltage, so the more stable the power output is. And we can see if we just do some quick multimeter readings, output of 12 volts with a 1000 microfarad capacitor, we drop that down to 10 microfarads, so much smaller in terms of its capacitance value, we get a smaller output across the load. Consequent of that is the bigger the ripple voltage, smaller the overall output across the load will be. If you wanted to change some of your load resistor values and start analyzing those, you simply just double click on the component, change the value, hit OK, stop and start your simulation, and then that will change the value. Don't forget, it's the voltage measured across, so all we're doing here is measuring a larger voltage drop.